Hey there, so we're going to continue with similar polygons, what we learned in 7.3, but now we're going to find some shortcut ways to prove triangles similar. Remember, similar means my angles are congruent and my sides are proportional. So just keep that in mind, what we learned yesterday, to help us through this lesson. So we're going to learn 3 ways to prove triangles are similar. The first way is AA similarity postulate. And remember that AA means angle, angle. So if 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. So the first one, AA similarity postulate, you need 2 angles to be congruent. So you can say that the triangles are similar. Just as a review, what we learned in the last semester, ways to find that those angles are congruent. The first way is vertical angle. So remember, it might look something like this, like a bow tie, and you have those vertical angles. Parallel lines with the transversal. If I have 2 parallel lines, and we'll see a lot of this today in our lesson, the alternate interior angles are very, very common, so watch out for that. You'll also have corresponding and alternate exterior angles. Of course, all right angles are congruent. If angles have the same measure, if 2 angles are 90 degrees or 80 degrees, then they're both congruent. And then the reflexive properties. So you might see a couple ways. There's one triangle, and then another triangle might lay on top of it, and they both share this angle up here. Another way is, I think of it as like a V. So there's one triangle, and here's another triangle, and they both share this angle right here. So just watch out for those 5 different ways to look for angles to be congruent. So let's find a couple, or look at a couple of these examples. Determine whether the triangles are similar. If so, write a similarity statement. Remember, a triangle is similar to a triangle. Explain your reasoning. When it says to explain, just state a postulate or theorem that you used. We just learned that you only need 2 angles to be congruent for our triangles to be similar. So let's look at our picture to see if they give us that much information. I do know that angle B already is congruent to angle D because they're both 42 degrees. So I know that those are congruent. So that's one angle. Remember, I need 2. So I'm left with a 58 degrees and an 80 degrees. So I'm going to solve for angle A and see if I can maybe find another congruent angle. So I'm going to use the triangle sum theorem, 180 minus 42 minus 58. I come up with angle A being 80 degrees, which matches angle E. So I know that angle A is congruent to angle E. So that's 2 angles. When I have 2 angles, we just talked about, I know that my triangles are now similar. So I'm going to say angle ABC, triangle ABC is similar to, I need to make sure I have corresponding parts. So A matches with E, D, F. And I know that they are similar because of the AA similarity postulate. Right, let's look at another example. In this picture, I have 2 parallel lines, so I need to determine if the triangles are similar, write a similarity statement if they are, and explain. So I'm looking for 2 angles because notice I'm not given a side length, so I know that I need to look for angles. So there's a few different ways you can look for this. So since I have these parallel lines, I know that I have a transversal, maybe here, I'll use this line. So I know that angle Q is congruent to angle N because they are alternate interior angles. So I have that angle is congruent to that one. And then I'm going to use vertical angles because that's what I see. So QXP is also congruent to, so Q matches with N, so NXM Because the vertical angles, remember, I only need 2 angles, 1, 2, to prove my triangles are similar. So I'm going to say triangle QXP is similar to triangle NXM. And I have an A into A, so I know I'm going to use the A similarity postulate. All right, go ahead and stop this video and try your next 2 checkpoints. And you can start it when you're finished. Here are your answer keys. Again, you might have gotten maybe a little bit of a different answer on that one. All right, 2 other ways we can prove triangles are similar. So the first one is SSS. We had a similar one to that to prove triangles are congruent, but in this one, I know that sides must be proportional. Oops. So my sides must be proportional. So I need all 3 sides to be proportional. If that happens, I know my triangles are similar. Remember, proportional means that when I set up my proportion, all of them are going to come out to be the same fraction, which means they have the same scale factor. That fraction, that ratio is going to be the exact same for all 3. So SSS is one way. The other way is SAS. Remember, when it says SAS, that means I need the angle that is congruent. My pen isn't wanting to work. The angle that is congruent is going to be the included angle. So I have a SAS. I have to have that included angle between those 2 sides. So remember, my sides that are corresponding must be not congruent, but proportional. And I need the included side, or included angle that is congruent, sorry. All right, so we have SSS and SAS. So let's see how we might be able to use some of those in our next examples. All right, number 2, you can solve this a couple different ways. We're going to solve it because I have all 3 sides that are given to me. I'm going to use all 3 sides, but if you notice, I have a vertical angle, so I could also maybe use SAS. So this can be solved a couple different ways. So when you are using SSS, we are going to pick the longest side over the longest side, short over the short, and then the medium over the medium. That way we can just kind of keep tabs on which side we've used. I'm going to call this triangle number 1 and this triangle number 2, so I can set up my ratios the same every time. I'm going to do triangle 1 over triangle 2. Again, you can pick it a little bit different. All right, so I'm going to pick the longest side on triangle number 1. So 9 over 6 would be my short or my longest side, which reduces to 3 over 2. All right, I'm going to pick the next one, my shortest side. So 6 over, my shortest side over here is 4. So 6 over 4, which reduces to 3 over 2. And then my last, I'm going to pick 7.5, my medium, over my medium. So 7.5 over 5, which reduces to 3 over 2. When I get done writing my ratio for each side, I'm going to compare the ratios per side. And notice that they are the same. So if they're all the same, I know that my triangles are similar. A, B, C is similar to triangle. And notice I go A, B, which is my longest side, so I need to pick A, E, or D, E, C for my other one. And I used SSS, Similarity Theorem, to solve. Right, not too bad. I could also, they might ask me, what's my scale factor here? Well, because they're all three the same number, my scale factor is going to be 3 to 2. All right, let's go to look at the next one. Determine whether the triangles are similar. If so, write a similarity statement. So I have triangle MNP, so this triangle right here. And then if you notice, I also have triangle MRS as my other triangle. So if you didn't recognize it, they both share, remember this angle right here, they lay on top of each other. So I know that angle NMP is congruent to angle RMS because of the reflexive property. All right, so I have an A. So let's look at, I don't have another A to use AA. So let's look to start comparing sides. So I'm going to say that MN, which is 10, is proportional to, and notice because my triangle is actually the entire length here, RM, I want to use 25 and not just RN, which is 15, if that makes sense. So make sure you use the whole length. That reduces to 2 over 5, all right? And my other side, I'm going to pick MP, which is right here, over SM. Remember, I need the whole length. So I'm going to say 12 over 30. And that reduces to 2 over 5. All right, so I'm going to compare. So I have two sides that are proportional, and I have one angle, which means I know that my triangles are similar. NMP is similar to triangle RMS because of the SAS similarity theorem. All right, go ahead and stop this this video. Do your 2 checkpoints and then restart it to check your answers. Here are your answers from the next 2 checkpoints. All right, let's look at our standardized test example. I have 2 triangles, RST and XYZ, I also have that they give me that RS over XY equals 2/3. So that's going to be my scale factor. Which of the following would be sufficient to prove that triangles are similar? Remember, we have SSS, AA, so 2 angles, all 3 sides, or SAS. So we need that information to prove triangles are similar. So let's look at our options. The first one, I'm only given that 2 sides are proportional, but if I look down here, I need at least all 3 sides, so that one is out. The next one is saying that all 3 sides are proportional, which would allow us to say that SSS similarity theorem could be used, so that's an option. All right, let's keep that. I'm only given that one angle is congruent. Again, not enough information to prove it by AA. And then 2 sides are proportional. If I added an angle, that might be, but again, not enough information to prove SAS. So my answer would be B. All right, and the last thing on this video, just the properties that you've seen before, but now we're using them with similarity. Reflexive just means one triangle is the same as the other triangle, which is true. Symmetric, I'm just flipping the order. Triangle ABC is similar to DEF, which is the same thing as DEF is similar to ABC. And then remember that transitive property. I have that connection piece. If 2 triangles are similar to the same one, then they would be similar as well. All right, this is video number 1 of 2. So we're almost finished with this lesson, so I'll see you in the next video.